How do pointers relate to memory allocation and deallocation? Imagine your computer's memory as a giant storage room. Pointers are like labels on boxes, telling you exactly where each item is stored. They are variables that hold the address of a specific spot in memory. When you need to store data, you use functions like malloc or null to reserve space in this storage room. These functions return a pointer to the start of the allocated space, so you know where your data lives. Once you're done with that data, you need to free up the space to make room for new information. You do this by calling free or delete and passing in the pointer. This releases the memory back to the system, so it can be used again. Properly freeing memory is vital because if you forget, the space stays allocated but unused. This is called a memory leak, and over time, it can cause your program to slow down or crash. Now here's where pointers get tricky. If you free memory but forget to set the pointer to null or nullpter, it still points to the same address. That means it's a dangling pointer, holding an address of memory that no longer belongs to your program. If you try to access or change data through this dangling pointer, it can cause unpredictable behavior, crashes, or data corruption. To prevent this, always set your pointer to null after freeing the memory. That way, if you accidentally try to use it later, you'll get a clear error instead of corrupting data or crashing. Debugging tools can help track down these issues by showing you where dangling pointers exist or where memory wasn't properly freed. In essence, pointers act as the bridge between your program and the memory it uses. They help you allocate space when needed and releases it when you're done. But handling them carefully is key. If you don't, you risk creating dangling pointers or memory leaks, which can be tough bugs to find and fix. Mastering how pointers relate to memory management makes your programs more efficient, stable, and safe.